Okay, in this video I'm going to be making a spinner. It's pretty much just a simple one, and then using xLights to map the wiring for me. I'll cut it out on the laser and then push the pixels in, create the wiring diagram, and then put it into xLights. So let's get started. First off, I'm going to start with just a pixel hole. I always use 11mm pixel holes because the material I use isn't extremely rigid. So if you've got a really rigid material, then use 12mm pixel holes for the bullet pixels, but I use 11mm. You test your material, you'll work out what's the best to use. Now I've got the 1 pixel here. I'm going to use the array tool. I'm going to make 15 copies. 15 and 25.4 millimeters apart. So that's basically 1 inch spacing from center to center. And there's one of the arms. If you wanted to add like bends, or instead of just straight lines, you can sort of make this sort of effect. And that's relatively easy. You just get another circle and kind of say like there. You're looking for this top bend. And then sort of just put that there. And then just click a pixel. Move your arrow down. You get what the idea is. You're kind of just using the circle there as a guide. So yeah, something like that. Obviously you're gonna want to make that a little bit nicer, but just for the purpose of this, I'll quickly show you. You can use the array tool, and then you'll see you'll get the same sort of shape as what we've got on that other spinner. But I'm just going to do normal, just straight ones. So we'll just back out of that. And yeah, we're just going to make a simple one for this video. But you get the idea. Okay, so now we'll just take these and we'll use the circular array tool. And I want to make 26 copies to match what I've already done. So yeah, now I've got that. So we're slowly building it. I'll get rid of that middle pixel, and then these are very close together. So what I'm going to do is I will take that lot out, and we'll take this lot out. Okay, so now I'm going to fill those in by just, we'll take another one of these, just paste that there, and we'll go back to the array tool, make 2 copies for that one, and then we'll do it again, and then we'll make 3 copies for this one. And then what I'm going to do here is I'll do a circular array again, but in this one I'm going to make it 8. I'll make 8 for the center ring, and then again I'll get rid of that center pixel, group those together, and we'll just move that off over there. Down there. We'll group this lot together just so they don't move around. Okay, and then now we'll do the same here, but I'll make 16 copies because this is going to be the second ring. And now I'll get rid of the center ring, and we'll group that. Okay, so now I'm going to put these rings in together. So first we'll highlight both of them, and we'll line the centers up here at the top, and then we'll copy that, we'll highlight that, and then we'll just, now we got it, and we'll center those. And then there we have it. So we have the the basic spinner built, which is that there. Now I just want to do the outside circle of it, so we'll get another circle, and then we'll go back there. So now we want to take the measurements from this, so we're 722 200. So we'll go 722.200. Okay, now we'll just turn off the aspect ratio lock, and then we are 717.15, so we'll go 717.015. Okay, now that circle will be the same size as that, so we'll lock that. We'll just lock the aspect ratio again, and then we'll click that one. I'm going to group those. Just group all of those together. And then we'll get that one, we'll get that one, and then we'll do the align centers again. That'll bring it in. So now we want to create just a bit of a gap around the edges, just so we're not cutting over the pixel holes. So we'll just highlight that one, and then we'll just push it out. With the aspect ratio locked, it'll move the whole thing together. And then there, so we've got almost a 10mm edge around it. And then that's your basic spinner. So we'll group it all together. And it's the same as this one, as you can see. Like I said before, if you want to do bent legs, more styles, you can do stuff like that. Okay, if you don't have a laser and you wanted to print this out as a template using a printer, so you can drill holes, use a drill, or cut it out, or however you want to go about it because you don't have a laser. The easy way to do that is we'll just highlight it, we'll change the layer to black because we're going to export it as an SVG. So for it's going to transfer the color to SVG, so black's going to be best for the printer. So we'll go export, make sure it's an SVG, just call it spin, and then we'll export it as an SVG. Now I'm going to use Inkscape, which is another free program. So we'll load it up with Inkscape. Okay, so now we have it in Inkscape. And then all we want to do is go to File and just go Export. That'll pop the side box up here. And then select PDF. Should be here, portable document format. And then just export it. So that'll give me a PDF on my desktop. The save path. So it's on the desktop. And then we can close Inkscape. So we'll close without saving. So we use Adobe Acrobat Reader to open the PDF. So there it is. We come up to menu and then just go to print. And then you go to poster. So that's going to print it across multiple pages. Just make sure you've got A4. And then, yeah, so you'll have 12 pages. And what this will do is this will print it out across multiple pages, and then you can just sticky tape them together, and then that'll be your template that you can use to drill or cut, or however you want to go about it. So that's one way to create things in Lightburn, and then put it on, like turn it into a physical template that you can use to stick to a bit of coral or something and drill the holes manually, you know, if you don't have a laser. Yeah, so now we want to, I'll send this to the laser, we'll cut it out, push pixels through it, and then we'll use a part of xLights to map the wiring automatically for us. This way we don't have to manually do it. Okay, for the next step of this, you need to have a controller that xLights can talk directly to, because it's going to display a pattern on the prop to map the wiring automatically for you. So you can just use your normal controller that you have, your Culp or Falcon or whatever it may be. I've made this. This is just an ESP8266 chip, a voltage regulator or buck converter, and just a little rail to take the power from here and run it out the leads. The data will run through the ESP board, and that'll talk to xLights, and that'll do all the magic. Good thing about this little box is that you can put 5 volt, 12 volt, 24 volt in here, and it'll always work, and the correct voltage will come out of the leads. Making something like this just purely for this function really works well, and yeah, it's fairly cheap. You're also going to need a camera to film the prop, because you're going to take a video and analyze it with xLights, and that will do the mapping for you. So you can use your phone, you can use webcams, you can use whatever you like really. I'm just using this cheap $40 action cam. It's nothing special. It'll do 1080p, which is all you need to do this. You want to use a tripod, or make sure your camera's still. xLights has a lot more problems detecting the pixels if the camera's moving, so of course set the camera still, and you'll get a better result. Okay, so now we're in xLights. We've got the controller set up, everything's ready to go. So what we want to do to map the prop is come to Tools, and then come down to Generate Custom Model. Now you're going to need to count your pixels, so you'll need to know the numbers of your pixels. In my case it was 336. I'll leave it on nodes automatically, and what this is going to do is this is going to talk to the controller, and it'll display the pattern on the prop. You'll get 2 flashes to key off the sequence, and then it'll run a short pattern, and then it'll tell you to stop. What you want to do is here with the intensity, don't jack this up. You will need to experiment with this, but I kind of find around about there, for my testing anyway. You can push this higher or lower, but if you push it really high, it just doesn't work very well, and if you push it too low, it's not going to detect the patterns, and it just won't work. So you will need to experiment with this, kind of just the first couple of times to get your camera right. Set it to something around about there. You can run multiple captures, create multiple videos. So if the first one doesn't work, jack this up a bit, shoot it again and over. Once you press run capture, you're going to get this pop up, which will basically, it's telling you that it's ready to go. So what you want to do is at this point, you want to hit record on the camera and then click this within something like 20 seconds or 30 seconds or something. I think Keith said it was 30 seconds. It needs to, at the start of the video. So the video can't go longer than 30 seconds or something without the key off pattern, which will be 2 bright flashes. You start the camera and then click this. And so you do that, and it'll pretty much run the flashing pattern. It's fairly short, and then you'll have that on your camera. So at this point, you stop your video, you bring your video to your desktop, and then you go to the Process tab. So in the Process tab, you want to click on Nodes again, Automatic, and then click Next. And in here, again, your pixel count, so it's 336. Video is steady because we've got it on a tripod. Leave this unticked. You don't need a preview video. So now you find your video that you took of the flashing pattern, and we'll put that in there. So once all of this is loaded, you click next and it'll run through, it'll do its sequence. It's basically analysing the video and looking for the pattern. It doesn't take very long, so just be patient. It'll do its thing. Okay, now, once it's done, it basically says here that this is the most likely to show all your bulbs, so they're all lit up as you can see, and you just click next. So now it's come up and it's detected 336 nodes, and yeah, so as you can see, each red dot indicates a pixel that's detected. You've got your model scale here and sensitivity, and guess location of missing nodes. So this is where you need to play around with the sliders and that. If you get your video good and your light good, like I've done with this because I've experimented a fair bit with this, so I know rough sensitivity and all of that, you'll see that it's pretty much nailed it. Like from what I can see, it's pretty much nailed the exact wiring. I just went around in a circle, so I started there and just went around and around and around and ended up here. There was my end pixel, and I think there was my start pixel. So with this, I can drag this down, say, just scale the model down. It doesn't need to be huge. I'll just make it 96 by 98, that'll do. Everything still looks good there. So I'm happy with that. You can click on advanced controls and mess with stuff there, but I think it's better trying to get the video that you record at the start better, and then you won't have problems here, or you'll have less problems. So anyway, we'll move on. So we'll click next, then we'll just pull that out. As you'll see, we've got a node layout. It's not 100% perfect, but either one, it'll do for this video. You can obviously adjust all of this, fine tune it later, but we'll save the model. So now we've saved it, and then we can get out of this. But I'll just go back. If you come to this point, when it analyzes and it doesn't find anything, doesn't pop any errors, and just constantly says 0, just can't find anything, just go into your settings, preferences, and go to other at the end and untick hardware decoding. On one of my machines, I had this ticked and it just would not find the pixels. So if you are having troubles finding the pixels, I don't know whether it's something specific to this analyzing function that Keith's put in here, but either one, turning off hardware video decoding solved on that machine. But anyway, we'll go to the layout, and then so we'll import, and then we'll take that model that we just imported, and then there we go. So we'll go to the controllers and go visualize. We'll just drop that there. So he's all happy. We'll upload that to the controller. And then there we go. We've got our start pixel there. It's hard to see, but the start pixel's there. So the controller, the prop's pretty much mapped. So we'll just go into the sequencer, create a new sequence. Okay, and then we'll just drop an effect onto it. We'll just take the house preview. And then there's the spinner. As you can see, the bar's going through it. So it's pretty much mapped at how we want. We'll go, so that's direction up, left to right, direction left. So you can see everything seems to be mapped pretty much okay, right? And then we'll go, say, where is it? We'll go to there, and we'll just do a pinwheel. Yep, let's do a pinwheel. Where's the arms? And then we'll make it thick. Yeah, there we go. It looks good enough. And yeah, so the prop's working. So that saved us having to click individual spots to make the wiring diagram and all of that, because that's a tedious process. So if we go to layout, click the prop, we can go to model data, and then you'll see it's in here. And then we will tick show wiring, so we can see the wiring there. And you can click the prop and then just go show, where is it, wiring diagram, wiring view. And then there you go. It's pretty much automatically created the wiring view for us. So while this is a simple spinner, you can do the same process on more intricate designs. This just makes it a lot easier than trying to manually do it. And like I said, you can go in there into the model data and then just manually change out the, if one of them's not in the, if one's, you can see it there, they're sort of not in a perfect line, you can kind of just go through and straighten them up. But you're not going to really notice it when it's out the front of your house with a bunch of other lights going. You'll barely even notice that there may be a pixel out of alignment. But yeah, then we'll do that, we'll send it to the controller, and then we'll see what the prop looks like. And there we go, that's the prop, showing you what's going from xLights. And yeah, fairly simple way to create a simple spinner and map it with xLights to automatically do the wiring for you. There you have it. That's how you make a spinner in Lightburn using xLights. I'll be making some videos doing some other props in the coming weeks. If you like that, subscribe, and yeah, you can watch on to see what else we get up to.